Hello, my darlings. Okay, so today we're going to look at the product rule. But before we do that, I'm going to start with a function that has a product, where we have a binomial times a binomial. So the first thing we're going to do is we're going to multiply to expand this, and we're going to simplify. So we're just going to, if you need to use the box method, you can go off on the side and use your box method. But 4x squared times 7x cubed will be 28x to the, remember you add the exponents, x to the fifth. Then we're going to do 4x squared times x to the first. So that's going to be plus 4x cubed. Now we'll take the negative 1 and distribute. So negative 1 times 7x cubed is minus 7x cubed. And a negative 1 times a positive x is minus x. And now we're going to combine like terms. I only have 28x to the fifths, but 4x cubes minus 7x cubes, that's minus 3x to the third, and we still have a minus x. So now we have our f of x. Now that we have that, we know how to find the derivative. Okay, so we're going to find f prime of x. We bring down our exponent. 5 times 28 is 140x, but now instead of to the fifth, we raise it to the fourth. It's one less. Minus, we take that exponent. 3 times the coefficient 3 is 9x. Subtract 1 in the exponent and it's squared. Minus the derivative of x is 1, and here we have our derivative. Awesome. Now, let's see what the product rule is. So the product rule, and I have this rule written in two ways, because the notations will vary based on your textbook or your professor. So I'm going to show you a couple different notations as we go through this unit. I'll have my favorite, you'll have your favorite, but this way you've seen it. Sometimes they'll show you f times g, take the derivative of x. And sometimes they'll say the derivative with respect to x of this product. But either way, it's equal to the derivative of f of x times g of x plus f of x times g prime of x. So what that says to do is that the derivative of the product, f times g, is the derivative of the first function times the second, we keep the second, plus, now this time we keep the first function times the derivative of the second function. Let's see how that works. So here is the same function that we started with, the 4x squared minus 1 times 7x cubed plus x. Now if we look at this as a product, we have our first part is 4x squared minus 1, and we have our second part is 7x cubed plus x. So if we use the product rule, the first thing we do is we take the derivative of f prime of x. So the derivative of 4x squared is 8x minus the derivative of 1 is 0, so we don't need it. Now we're supposed to keep the second function, 7x cubed plus x. Then we need to add. Now we're going to keep the first function, 4x squared minus 1 times the derivative of the second function. So the derivative of 7x cubed is 21x squared plus the derivative of x is 1. Now, unfortunately, you're not done, because at this point, we need to do algebra, your favorite thing, right? So here we go. F prime of x, we're going to say 8x times 7x cubed. That is 56x to the fourth. We're going to do 8x times x, so that's plus 8x squared. Then we're going to go to the next part. We have 4x squared times 21x squared. That's going to give us plus 84x to the fourth. And 4x squared times 1 is plus 4x squared. A negative 1 times 21x squared is minus 21x squared. And a negative 1 times positive 1 is minus 1. Now, if we combine all our like terms here, f prime of x equals, how many x fourths do we have? 56 plus 84, that's 140 x to the fourths. How many x squareds? We have 8 plus 4 is 12, minus 21 is going to be minus 9x squared, and don't forget that minus 1. And if you look back to the top of your paper, that's the exact same answer we got by multiplying the function first and then taking the derivative. Now, yes, I'm going to be honest. You're right. It was easier the first way for this particular problem. Sometimes the product rule is easier. Sometimes it's easier to multiply first and then take the derivative. But there will be times where you have to use the product rule. For instance, if you have sine times cosine, you have to know the product rule in order to take the derivative. Okay? Let's try another example. Now I want to do this by the product rule method. So when we look at this, we have our first part is x squared minus 1, and our second part is x squared minus 2. So to find the derivative of f of x, we take the derivative of the first part. Now the derivative of x squared is 2x times, we keep the second part, x squared minus 2, plus, we're going to keep the first part, x squared minus 1, and we're going to multiply by the derivative of x squared minus 2, which is 2x. Notice I switched the order, but we know that multiplication is commutative, so it doesn't matter which order we put the 2x and the x squared minus 1, okay? It's just easier to remember to distribute if your monomial is in front of the binomial. So now we just have some more algebra to do. 2x times x squared is 2x to the third. 2x times a negative 2 is minus 4x. Then we have plus 2x times x squared is 2x to the third. And we have 2x times negative 1, which is minus 2x. And when we combine our like terms, f prime of x is 4x to the third minus 6x. Now, we can check that. If we take our original function f of x is x squared minus 1 times x squared minus 2. If we multiply x squared times x squared, we get x to the fourth. X squared times negative 2 is negative 2x squared. If we distribute the negative 1, we'll have minus x squared and then plus 2, which means that our function f of x is x to the fourth minus 3x squared plus 2. And now if we take the derivative of our expanded function, the derivative of x to the fourth, bring down the 4, decrease the exponent by 1, minus 2 times 3 is 6, x, decrease the exponent by 1, plus the derivative of 2 is 0, so we don't need it. This is the same answer we had. It worked. All right, guys, have a great day, and I'll see you soon. Bye.